Okay, welcome to the fourth session here of learning some of the basics of R and the tidyverse and programming and things like that. In this session, we're going to be looking at data visualization. I know I've touched on this a little bit in some of the earlier sessions, but we're going to take a deep dive into GGplot and looking at how we can make some nice looking visuals in R. So as some sources for this, I'm going to be basing this session around loosely around these two texts, both of which are freely available online. Fundamentals of Data Visualization by Wilkie, and then Data Visualization, A Practical Introduction by Healy. The book on the left focuses more on theory and best practices about data visualization in general, while the book on the right does the same, but then extends this with actually all the code in R to produce all the visuals and takes you through everything to do with GGplot and how to produce publication and publication-worthy figures in R. So those are both freely available online as open text that you can read and access the actual source code and everything in those books. So that's what I'm using for this session. All right. So what is data visualization? Sort of why do this? Data visualization is sort of part art and part science. The challenge is to try to get the art part right without sort of getting the science bit wrong. So we can think of, at a very high level, any data visualization is basically a tool for communication, communicating between the data and you, the analyst. When you're trying to understand your data, it's a useful tool there, but also as a tool for communication between you, an analyst, and some sort of an audience, whether that's a scientific audience or a popular audience or whatever that audience might be. It's a tool for you to communicate the nature of your data or the results of your analysis and things like that. So we can use these tools, and we mustn't mislead or distort with them. But they must also be aesthetically pleasing, and we'll talk about some of those things throughout this session. So how we can balance truth in the data with having data visualizations that are actually useful and display the data correctly and are visually pleasing. So you ask yourself, well, why visualize data? What's some of the things we can get out of this as analysts? There's many reasons to visualize data, but generally think of sort of two things. We want to understand our data, and looking at your data is actually one of the best ways that you can understand it. So that's the first way, and then the second way I just spoke about there is we want to communicate with an audience. So any sort of visualization it's one of the most powerful ways to get an idea across to someone else. So to communicate a pattern in your data, or to present data that illustrates some sort of relationships or whatever the case might be, a visualization is normally a really good way of going about and doing that. So I have an example here which some of you might have seen, but it's an example which hopefully illustrates the importance of visualizing your data rather than just looking at summary statistics. So this figure here is called Anscombe's quartet, and it uses 4 scatter plots showing the relationships between 2 variables, so height and age or income and time, for instance. Each of these 4 they're made-up data sets, so they contain 11 observations, so that's 11 rows in each data set. And for each of them, the numerical properties, so the means, the standard deviations, and the correlations between the variables are identical. So in the first panel, it has the same correlation as the second panel, as the third panel, and the fourth panel. So if you were to just look at a summary statistic, so the means, the standard deviations, and the distributions and things like that, they would be the same. But clearly, if we then go and actually visualize as a scatter plot here, we can see that these differences are obvious, that these are clearly very different data sets. So hopefully that, just as a quick illustration, gets across the importance of always looking at your data. Now, both of these books spend a lot more time focusing on the why, and especially Kieran Healy in the beginning, the first 2 chapters there. I've done a number of sessions at other times on fundamental principles of data visualization and things like perception and things like that. So it is worth, if you're interested in that, going through those sections. But I'm going to focus in the rest of this specific session on actually how do we do this in R. So the nuts and bolts of producing good visuals in R. So both the books will go into a lot more detail with a lot more examples, but I'm going to sort of deep dive into this and hopefully get you going on the path to producing good visuals in R. All right, so R has many different systems for making graphs. So there's some in base R. There's a number of different packages for that. But ggplot 2 is one of the most elegant, versatile, and sort of widely used methods for making good figures in R. It's part of the tidyverse, so you can import it there, or you can import it separately like that. So let me just run these. I've got it now loaded into my program. And what ggplot does, or what the GG stands for, is the grammar of graphics. So essentially, it specifies a grammar which enables you to produce good figures. It's a coherent, almost like language that you can use for doing this. So if you're interested in more of that, I do warn you, it gets a bit technical, but this is Handley Wickham's thesis, where he actually created ggplot within this layered grammar of graphics. So you can look into that, but it is a bit technical, and it's way beyond what you necessarily need to know to be able to work with ggplot. All right, so what makes this a great visualization system? Why ggplot? Why is this worth working with? You'll come to see in some of the code that we'll go through in this session that the code is more elegant, it's more compact than with base R. It's very powerful for exploratory data analysis. It follows a grammar, just like any language. So like with tidyverse, we can chain things together. Same thing with ggplot. So there's a few fundamental basics you've got to get, and then you can build these things up into very advanced analyses. It defines basic components that make up a sentence, and we can then combine them together. And I'll show you at the end of the session, there's a lot of different add-ons for ggplot. So the basics are very powerful, but if you want to do very advanced types of figures, there's a package for that you can plug into ggplot to expand the functionality. All right, so let's see how it actually works. So I'm working down here, looking at the actual grammar. So the general call for any ggplot looks something like this. So this obviously won't run because there's no data yet. But basically, the grammar involves a few core things. So the first thing is the actual data. So every call needs to have a data frame that you pass to it in some way. So data equals, and then you give the specific data frame. And then we have here this AES, and that's basically called aesthetics. So it's not about the visuals of the figure, it's about the aesthetic mappings. And what do I mean by that? Basically, it's the mapping of variables in your data set to components in the figure. So in this case, X and Y, those are two components of a figure, the axes. So you can say which variable is on the X-axis and which variable is on the Y-axis. Other components, other mappings, you can have which variable is represented by color, which variable is represented by size, shape, fill, and so on. So essentially in the AES component here is you say the various components of a figure, which ones map onto the different columns in your data set. And then you can see here with the plus, we added geom, so a geometry. So the geometric objects in a plot, basically, what are the lines? What are the polygons? What are the circles and bars and shapes and things like that? So think about, you build up a figure in layers. You first say, this is the data. Then you say, these columns map onto these components. And then you say, use these geometries to represent different things in my data set. So that's the general sort of high-level idea. Let's look at an example to see how we're going to do this. So I'm going to use the Gapminder data set. So if I just import that into our environment, if you remember this data set, we've got six variables: year, population, continent, life expectancy, and GDP per capita. And we've got 1,700 rows for a bunch of different countries and years. All right, so first thing here in this example is I call the ggplot function. So now it knows that I want to do that. And I say data equals gap. So basically I'm saying use the gap data set. And then I can say which variables do I want on the various axes. So I'm using AES. I'm saying the y-axis is going to be GDP per capita, and the x-axis is going to be life expectancy. Now there, if I were to run this, that wouldn't actually do anything because I'm just saying set it up. I haven't told it which geometry do you next need to use. So then I say plus geom point. So if we were to type in geom, you'll see that it gives us all the different options here. So there's a lot of them. But geom bar, geom blank, geom box plot, column, count, cross plot, and so on. We'll come to look at some of these in this session. So let me run this and you'll see what we get. So that's what we get as a basic first plot without any tweaking, any adjustments, anything like that. We have on the x-axis life expectancy, and we have on the y-axis GDP per capita, and we've told it to put that as a scatter plot. So that's what we've got there. So we've told it how we want to visually represent it with the geometries there. So let's look at this at another higher level here. So generally, you can think of any plot that you might see in any kind of paper consisting of 6 elements. So some data, in this case, GGplot works best with tidy data. So some tidy data, and then a mapping from the data to elements in the figure. So that's in the AES component. And then on top of that mapping, we then have various geometric layers. So that's the dots, the lines, the bars, and so on. And then you have various coordinates. So we'll talk about that in a second. And then you have the scales. So that's at what scale is the information represented. And then you have labels and guides. So that's basically labels to various things on the figure. Guides are legends and things like that. I've indicated these in this order from 1 to 6 because generally when we're building up a plot, we can think of these as different layers. So you start off with the data and then you move through these layers one by one. So in this case, this was only 2 lines. Just this morning, I was building a figure for a paper which was 250 lines of code just to build up a relatively advanced figure. But it's just layer by layer, adding different components to it and different bits and pieces and things like that. So the most important thing to get used to with GGplot is the way we think about this logical structure of the plot. If you can get that down, so that's why I'm kind of going over this a bit repeatedly. The actual nitty-gritty of making very pretty looking figures is quite straightforward. So the key thing here is thinking about the code that we write. It specifies connections between the variables in our data, the colors, the points, the shapes you see on the screen. And these connections that I have here, we think of them as mappings or as aesthetic mappings. And every plot you begin by telling GGplot which components, which columns from my data map onto which aspects of a figure. And then you take the result and you say, what general sort of plot, or is it a scatter plot? Is it a box plot? Is it a bar chart, and so on? So, as I said, the overall type of plot is called a geom, and each geom has a function that creates it. So, for example, geom point makes scatter plots, geom bar makes bar plots, geom box plot makes box plots, and so on. And we can combine these with a plus. So this is what I have here with a basic template of any GGplot that you might create. So you call the GGplot function and you say data equals data, and that's whatever data frame you're working with. Then you could say mapping equals AES, and then you can map from one aesthetic to a variable, another aesthetic to another variable. So X is equal to this variable, Y is equal to this variable, color is equal to this variable, fill is equal to this variable, and so on. You won't always need every aesthetic. So for instance, in this figure, to make this, I only needed X and Y. I didn't need to tell it what colors and fills and sizes and different things like that. And then with the plus symbol, you add a geometry. And you will see in a couple of minutes how we can have more than one geometry. But at the very least, you need one geometry. Then we can add scales. So this is scaling different variables. So scale X, scale Y, if you want to do the Y-axis or the X-axis, and so on. And then we can tweak the coordinates, and then you can add various labels, so titles, subtitles, and so on. And then the thing I don't have here, which we'll talk about in a second, is different themes. So you can change the look and feel of the actual figure. And this basic structure, these 6 or 7 elements, is pretty much every ggplot that's out there. So if you can get that down and understand this principle, then you can do basically anything with a ggplot. All right, so let's start with making a first plot. I'm going to start simple, and then we're going to build this and get more and more complex. So say here we want to look at life expectancy versus GDP per capita for all country years in the data set. So the first thing we need to do is tell GGplot the data we're going to be using. So I say GGplot, this is the data, Gapminder, and I pass this to the variable plot. So two ways you can do this. I don't have a strong preference. Many people use this way, where they say GGplot, my data is equal to Gapminder, and they assign this the label plot. The alternative is to say take the Gapminder data and then pass it to GGplot and call this plot. Both of these will give you the exact same result. It just depends what you want to do. So for this first one, that's when you're passing the entire data frame without any kind of adjustments. For this one, you might find that you might need to do some mutations. So oftentimes what I need to do in figures is I take the data set, I might select certain columns, and then, sorry about that, and then I might perform some mutations, and then I pass it to GGplot. So that's the one option there. This option here is you're just giving the entire data frame without any changes to what's going on. Both of these will give you the exact same output, whether you do it that way or that way. No difference there. So I need to, that is Gap, not Gapminder, sorry. So if we run this here, that should then work. Yeah, so we've now got our data set. So we've got our data, but not the mapping. So then we need to tell GGplot which variables, which columns map onto which components of the figure. So think of this mapping as saying the variable on the x-axis is going to be GDP per capita, and the variable on the y-axis is going to be life expectancy. There are other mappings, so we could use colors, we can use fills, we can use groupings, we can use sizes. Basically, this mapping argument links the variables in our data to the things that you'll actually see in the plot. It doesn't actually say what particular color or shape will be on the plot. We'll talk about that later, but it says which variable will be represented by the visual element color or the visual element shape, or in this case, the visual element point. So we're saying this element point is representing the combination of life expectancy and GDP per capita. We're not saying that a particular point or anything like that. Great, so where are we here? So if we run this, you shouldn't get anything because we haven't told it what it should actually look like. So let's add a geom. So the geoms basically tell it what will things actually, what will it look like. So here I've given this, sorry, that needs to be Gap. Let's run this and see what we get. Now we just need to output it. So what I've done is you need to tell plot to print, to get it out. So there we have that. I've just flipped the axis. It doesn't really matter with this particular analysis. I've just put life expectancy on the y-axis and GDP per capita on the x. It's to some extent irrelevant. And that's basically it. So this kind of recipe is tell GGplot what the data is, tell it what relationships you want to see, so the mapping, how do you want to see those, so that's the geometry, and then which other layer geometries do you want to add on, and then now we can look at some additional functions. So we can look at adding labels or scales or other sorts of details. So let's see a figure here where we add two geoms. So we've got our standard scatter plot here, but now we actually want to add a layer to it with a trend line, for instance, in this case. So what I'm doing here is I'm taking the same data that we have there. The data is Gap. These are the mappings between the x and the y variables. We're adding the point geometry, but now let's add a smooth geometry. So smooth is for a trend line, and then let's print out plot and see what we get. Sorry, we have data equals Gap. That needs to have a comma there. Sorry about that. So if we run this, we get, it's computed a trend line, and we can see which function that it's used there, and that's the actual formula that it's used to compute that trend line. So it's using a method called GAM, And in this case, it's fitted a generalized additive model to the data. So this suggests that there might be some other methods we could use to describe this if we want to perhaps have a linear model or something like that. So if we look in this case, same code as before, but I've just told it instead of figuring out which trend line might best describe the data, I explicitly want it to be a linear model. So I'm saying method equals LM. So it's going to plot a linear model, and we can see that that is the linear trend line in our data. We don't have to tell geom_point or geom_smooth where the data was actually coming from, because they pick it up. They inherit that from the actual GGplot object there. So that's that there. So if we look at our plot, the data looks quite bunched up against the left side. So GDP per capita is not normally distributed across the different country years. We can see that there's a bunching there down at the bottom. So this x-axis would probably look better if it were transformed from a linear scale to a log scale. Now I'm sure many of you with COVID-19 data are seeing log scales and things like that. In GGplot, that's very simple. It's just another layer we add on to the figure. So in this example, this is the same basic structure that we have here, our mapping, our various geometries, and then I say, let's add a scale to it. So by default, the scale is just whatever is represented in the data, but now I want to say it's a log 10 scale. So I can just say scale underscore x underscore log 10, and now it will be on a log scale. So now we've adjusted the x-axis, and we've dealt with that bunching up of the data. We'll deal with the x-axis labels shortly. You can obviously do the same thing with the y-axis. If you had scale y log 10, that would do the same thing there. The nice thing with the structure is if we can go like this, plus scale, and you'll see then that all the various options for scale come up. So scale color, scale, let's do scale x, and these are all the different options. So continuous, date time, discrete, log 10, reverse, square root, and so on. There's lots of different options, there. All right, so we've got our log scale, and we have some information there, but we want to transform, and we want to look at the to have the scales in a little bit more, a little bit clearer to understand. So let's deal with that. So again, same structure here. We're adding the various geometries. We add the scale x log 10, but no one can read that. That's not easy to understand. So we can use the scales package, and we can say the labels must be in dollar because it's GDP per capita. So let's run this and see what we get. So now it's in $1,000, $10,000, and $100,000. That's much easier to understand. So the scales package is part of Tidyverse, so you can load that there. But the labels are clearer to understand now. So we can see across these 1,000 observations the relationship between life expectancy and GDP per capita. So you can see here, I'm taking you through this process layer by layer. So starting off with the data, then the mappings, then a first geometry, then a second geometry, then you can tweak the scales. And this should be the process that you think through when you build up a figure of what are the different layers that's going on there. All right, so they're represented now as dollar amounts here. So two things to be aware of with scaling. You can either directly transform your x and y axis, as I've done here, so scale x log 10. So in that case, the axes will be transformed, and the tick marks of the axis will be labeled using scientific notation, as we had in this original example. Or you can give these, and then you can use these scale functions to give them actually useful labels. I would say that's the best way of going about doing it like that. So let's take a look at color. So we haven't dealt at all with color, and let's see how we can do that here in GGplot. So how do we specify specific colors? So we've learnt about X and Y as two aesthetic mappings. Let's try color. So I've got my same structure here where I tell GGplot what my data is. I have my mappings. then I'm adding geom point, and then I'm adding I'm changing the scale there. So nothing changed there. But what I've done in this example is, what happens if I try adding, say for instance, continent to color? So let's run this and see what we get. So now each point on my figure is colored based on the continent it represents. And GGplot has automatically created a legend for us. So we can look and see, okay, where Africa versus Europe and Asia and so on here in our data set. We can use more advanced themes to use more intuitive and useful colors, but for now this is quite nice. There's a lot of packages you can add in here to GGplot that makes it sensitive to color blindness and sensitive to being printed out and grayscale and things like that. This is quite nice, but what happens if I wanted to change the color of the points but not on the basis of a particular categorical variable in my data set? If I want to change the printed color, so I don't want it to be, in this case, color mustn't map to continent, but I want all figures, all dots to be purple or red for some reason. How do I do that? Do I do it the same way? Do I say color is equal to red or something like that? No. So that's an issue that a lot of people, a trap a lot of people first fall into here. So this AES function, that is for mappings only. So that's for mapping columns in your data frame to aspects of your data sets. So even though I say color is equal to continent, what I'm actually saying is the color component of this figure must be mapped onto the continent variable. If I actually want to set color in my data set, in my figure, we don't do that in the mapping. We do that in the actual geometry. So if I want to change the color of a given point in my geom point, I actually do that here in my geom point. So I say, we do my mappings here, and then I can say geom point, the color of the points is equal to purple, and then alpha is just basically how solid is it? Is it very see-through or very solid? So let's run this and see. So here, what I've done there is I've set the actual points to purple, rather than mapping a component of the figure, in this case, continent, to a specific color. So there's no legend. We've just changed simply changed the color of the points. So the various geom functions can take different arguments. So again, this is that same. If we go back to the original figure here, we've got data is equal to gap. I'm mapping GDP per capita to the x-axis, life expectancy to the y-axis, and a continent to the color component of the figure. We're adding a geom point. They're going to be black because that's the default color, but I'm setting the alpha is equal to 0.3, so they're a little bit see-through. And then let's see what else we have. So for geom smooth, I'm saying the method is LM, so we're going to have a linear model. I'm going to say we don't want the standard error, so that's the variance around the model there. The color is going to be orange, and I'm going to set the size of the line to 3, and we're going to have this on a log scale. So let's see what we have there. Orange. It's not a pretty figure, but you can see how layer by layer you can build a figure up and change the various options. Now, I know a lot of these just off the top of my head because I've been working with GGplot for quite a long time, and I program figures daily. But this is something that you build up over time. So when I was first doing this, what I would often do is for geom smooth or whatever the case might be, I would constantly look in the help files, look for what are the options for geom smooth. So here that's a question mark geom smooth, and then you get information about it here. So what are the different mappings? What data does it take in? What are the different method options? What does it do? Or same thing for question mark geom point. Same thing. You can look up the various options there. So you build this up by looking through the documentation. It's not something I know off by heart, or geom jitter, whatever the case might be. You can find the information there in the actual help files to learn how to do this. And I'll give you some recommendations at the end of the session for some other help on this. All right, so that's the basics there. But what about now we can add some labels to our figure? So we can use the labs option. So I'm going to show you quite a lot here, so don't be too scandalized here. We can use the labs option to add more to our figure. So it's the same basic structure. Remember, we're just building this up layer by layer. So we start off with the gap data, then we add our aesthetic mapping, then we add our first geometry, which we're going to change it from being solid to a little bit see-through. Then we're going to add our smoothing line, our trend line. We're going to turn off the standard error. Then we're going to set the x-axis to be on a log scale. And then what we're doing is we're going to say plus, add labs. And within labs, we can add different labels to the figure. So we can say x is equal to, in this case, GDP per capita, because we don't want to have the actual variable name. We want it to be something that looks nice for people. Y is equal to life expectancy in years. Title, we can add a nice title to the figure, so economic growth and life expectancy. We can add a subtitle, so data points represent country years, because that's what the actual points represent. And we can add a caption at the bottom, which is then the actual source of the data. So that's the first bit there. So let me select that and run that, and you can see what we get. So we run that, and we run that. So that's what that looks like there. So it's the same figure, but now we've added labels to it. The reason why we get multiple trend lines is because Geom Smooth inherits that from the color option there. So that's the first bit. What's all this other stuff that I've added to the figure? So GGplot comes with a bunch of themes. So if I go here, I type in theme underscore, then you can see black and white, classic, dark, get, gray, light, line draw, minimal. There's Cleveland, transparent. There's a bunch of different themes that come built into GGplot. So I'll show you some of them in a second here. So we can go classic. Let me just clear this and move this to here. Then I can run this all at once. So if we go classic, that's what we should be seeing now. So theme classic, that's a classic theme. We can go theme dark. That'll be a dark image. And so on. There's a bunch of different themes. So we can look at some more advanced ones. So these are from GGpubber. So we can say, okay, let's have a Cleveland theme and run this and see. There's a lot of different packages out there. So I don't have that package actually loaded. That's not a problem. So I normally prefer something like theme minimal, which is a minimalist theme, or theme BW, which is a black and white theme. There's different options there, but you don't want something that complicates your data. So if we look at that with just theme minimal, you'll see what that looks like. So that's theme minimal. So we don't have too many different things cluttering it other than our actual data. So that's the first thing you need to do. You add your scales, then your labels, then you add a theme, and then we can actually tweak different elements of the theme specifically. So here, using the theme function, we can say, well, where do we want the legend? So legend.position is bottom. There's close to 200 different options that we can give here, but I'm saying legend at the bottom. I want there to be no minor grid lines. I want only major grid lines. Often these are personal preferences. What color do you want the caption to be in, and so on. So let's see what this actually looks like if I run that. So that's a whole figure that I've built here. So I've said this must be gray. I want an axis line like that. I want my legend at the bottom. I want these at an angle, and so on. So this is a bit of experimentation where you build up a figure like this. But I hope you can see that all I've done is just added components one by one. So I've told it what the data is, what the aesthetic mappings are. Then I've added, in this case, 2 geometries. I've tweaked some options for the geometries. You can change the scales based on different options there. Then I've added labels to my figure. Then I've given it an overall theme. And then I've tweaked different components of the theme to make it look like how I want it to look, and so on. And you can see how I end up with 250 line options there. What's quite nice with this, though, is not specifically for this figure, but for a lot of figures that I use in publications, is I spend a lot of time developing a general theme. So different components. I always want certain colors, colors that are not biased against colorblind people, colors that can print well. I want different elements in my figures, font types and things like that. And then I just copy that into every figure that I use. I don't have to create it from scratch every single time. there might be certain elements that might not make sense in one figure or another. But in many cases, once you've made this once, you can copy that and use that, use your theme across many different figures that you've created. So in this case, in this lesson, I can just copy this and add it to more and more different figures without having to write that specific code every single time. In many cases, it's just your mappings that change from one figure to another. But I think that's a relatively decent looking figure here in our data. So let's now look at some line charts, some grouped data. So I hope you can see here that this is just copying from my other data set. Sorry, what is going on here? Gap minus. So I need to change the name of the data to gap. So let's just run this. So here, what I'm doing is I'm adding a different line to it, and I don't want to have the trend line for every single country. I want the trend line for the overall data. So what's the difference? What have I done differently here? So in this first line, you see that we end up with trend lines for every single consonant. So why is that happening? Here in color, I'm mapping that to the consonant column. So this is the overall aesthetic mapping for the entire theme, for the entire figure. This is in the GGplot function there. So all these different geoms, so in this case geom point and geom smooth, they inherit that mapping. So they take that mapping from here. So X is going to be GDP per capita, Y is life expectancy, and then color is consonant. So every single geom I add will have that mapping built into it. So here, geom smooth inherits that mapping, so it knows that it needs to make a smooth line for each consonant. So that's what we end up in this figure. But that might not be so intuitive. That might not be something that we're interested in. So what we do here in this figure is at the high level in GGplot, in the original function, I say X is GDP per capita and Y is life expectancy, but I don't map color there. I want the points to have the color, but I don't want the lines to have the color. So we add that mapping only when we need to. So this is another option that you can do. So here in geom point, I'm saying alpha is equal to 0.3, and then I'm adding a specific aesthetic mapping just to that point. So in most cases you don't need to, but here I don't want the smooth line to have that mapping. If I did want every geom to have the mapping, you would put it there. So for this figure, I want every geometry to have the X is GDP per capita and Y is life expectancy, so that's there. But I only want the points to have the consonant mapped to the color component. I don't want the smooth line, so I haven't done that there. I've added that as an extra aesthetic mapping, but just for the geom point geometry. So that's the only difference. The rest of this I've copied in the same as we had originally, and then if you look at what that does is the points are now colored based on consonants, and we have that here in our legend, but the smooth line, the trend line, is only for the overall full data set, because I haven't given that as a specific mapping for that. I hope that makes some sense. If not, just work through the example and you can see what I've done there. But you can see here, you can just copy in these theme components from figure to figure without having to retype them all the time. All right, so let's take a look at grouped data and making a different type of chart, some line charts. So here, again, I'm going to be using the Gapminder data set. And I'm going to be mapping X to year in this case, and then Y to GDP per capita. So I want to see GDP per capita changing over the years. And instead of a geom point, we're going to be adding a geom line. What's also different about this example is for the line example, I want to group it by country. So if we look at our data set here, we can see that country is a column. So it's going to group that by country. Why do I need to do this? Because geom line, if I did not do this, it would plot vertical lines at each year marker. So it doesn't know, it would add all the values for each country together. It doesn't know that they need to be grouped together. So we need to tell the layer we want to group by country, and that means that each country's data will be treated separately. It doesn't intuitively know that if we don't say group Afghanistan's data together and group Albania's data together and Algeria's data together and so on. We need to actually tell it to do that. So let's see what we get with this. So it's messy. It's fairly rough output, but basically this is showing the data properly. So each line represents the trajectory of a country over time. This outlier here, if you're wondering, that is Kuwait, for whatever reason. So it's messy, we can't really see much, but basically the group aesthetic is usually only needed here when the grouping information that we need to give to the ggplot is not something that's actually built into the variables being mapped. So for example, when we were doing points here, when we were plotting them by continent, mapping color to continent was enough to get the right answer because continent is already a categorical variable. So if we were to look here, we can see that continent is categorical. It knows what that is. So the grouping is relatively clear. But when we're wanting to map X to year, in this case, there's no information in the year variable itself to tell ggplot that we want to draw lines based on country. It has no idea, no way of knowing that. So that's why we needed to do that there. So that's why we need to say explicitly, put GDP per capita by year, but group it together by country. Okay, so this plot, I think, is impossible to actually tell what's going on. It's difficult to follow. There are way too many lines. We need a way of actually visualizing this data, but making it more clear for us as the reader or for someone else as the reader to actually understand what's going on. So one option is to facet the data. So this is what we call small multiples. So we take some third variable and we facet it. We break it up into, we call it a small multiple, where there's multiple versions of the same plot that are smaller based on a third categorical variable. So this is quite a powerful technique as it allows you to visualize a lot of information very compactly, and it's consistent and it's comparable. So you can compare one small multiple to another. So you'll see in a second here that we draw a separate panel for each value of our faceting variable. So for each category of our faceting variable. So facets are not a geom, but they're another way of organizing a bunch of geoms. So in this case, let's see what we're going to do. So we're going to take our same plot. So this is no different here, where we've got the gap data. We're saying X is year, Y is GDP per capita. We're doing a line plot, and we're grouping it by country. What I'm doing is I'm also adding a smooth line, which is going to be the trend line. But here's the difference. So that's our original plot. Here, now I'm saying wrap this in a facet. I'm going to categorize it by continent. So facet wrap. And this is called the tilde. It basically is what we use for specifying formulas in R. So we're going to, we can do very advanced faceting, but in this case, we're just going to facet it by continent. And then I'm going to give it labels year, GDP per capita, and a title GDP per capita on 5 continents. So what do we get? All right, so faceting can get very advanced, and we might deal with that, but at the moment, you can see here that I've taken the same plot and I've split it up by the continent variable. So we've got Africa, Americas, Europe, Asia, Oceania, and so on. And for each of these, we have a trend line across the entire continent. And then we have in black the actual specific values for each year for a given country within that continent. So here we've got the y-axis, which is not repeated because it carries through. So you can easily compare Americas to Africa. And at the bottom here, we've got the x-axis, and you can see here that we can compare up from Oceania through to Americas. So that's relatively straightforward. I'm sure you might have seen some of these with COVID-19 data and things like that. So that's the basic way in which we do that. Of course, facet wrap can be combined with all the other components that we talked about here, so with themes and with labels and everything like that to make it a much prettier looking figure. But that's the basic idea of splitting up something based on a third categorical variable, based on a grid like that. You can also move the labels around the grid, and there's a whole bunch of functions you can use to reorder the grid, but you can deal with that if you need to. This is the basic idea there. Okay, so that's the basic flow here of GGplot. Let's now look at some of the last few things here, scales, guides, and themes in a bit more detail. So as I've shown you, every aesthetic mapping has a scale. If you want to adjust how that scale is marked or graduated, then we use a scale underscore function. So we saw that here. We use scale underscore x log 10. So that's putting the x now on a log axis. What am I doing here with scale y continuous? Is I'm saying scale y. So that's now going to be the y-axis. So it knows what I'm referring to. And in this case, what is our y variable? Life expectancy. So that's a numeric variable. So I need to say it's continuous. If it was categorical, it would be scale y discrete. And we can see that here. So scale underscore y. And we can see the different options. So binned, continuous, date time, and so on. And luckily for us, you can see here that it gives us lots of the options. So name, breaks. Breaks are where the various lines come, minor breaks, and so on. There's lots of different options there. So what am I saying here? So I'm saying breaks is equal to the sequence from 0 to 100 in 10. So if we look here, our axis goes from 0 to 100, and the labels are in tens. If I had that as 5, it would go up in 5s, or 15, and so on. And then what do I say here? I'm saying the limits of the axis are from 0 to 100. So don't go any wider than that. So that's scales. And there's scale X, there's scale Y, there's a bunch of different ones that you can use for that. So we can use the scale underscore functions there. Guides is for the legend, and we can use the guides function directly to manipulate aspects of our legends. And Kieran Healy talked more about that in the textbook. And if we look at themes, I went through that here, but let's take a look a little bit more there. So you add a general theme there, and then here we can detail specific components of our theme. So what do I have? So plot.subtitle is basically we can then reference components to do with the subtitle. Plot.title is aspects of the title. Axis.text.x. So all these different functions here, we can manipulate different parts of our theme. So what am I doing here, for instance? I'm doing panel, so that's the entire panel, dot grid. So that's the specific grid lines, dot minor. So there's major lines and minor lines, dot x. So that's now on the x-axis. And then I'm saying set that to blank. So if you look here, we don't have grid lines in between our breaks. A lot of this is personal preference, but you can slowly but surely build up a bit of a library of tweaks you like making to figures. So I think for this session, the main thing I want you to take away is this part. So building up from data to the aesthetic mappings, adding different geoms, tweaking them as you need to, adding different scales based on what you need, and then adding some labels, and then ending it off with a generic theme. There you are 95% of the way to having great figures using GGplot. And this last bit here of tweaking the theme comes with a lot of practice and playing around. All right, so this last bit here, I just wanted to show you one or two quick figures that you can make here with some of the expansions to GGplot. So let's look at that in a second here. Let's just run this here. So in this example, this is a bar plot with color, with the fill based on different continents. So it's not a particularly nice looking plot, but some other things we can do here. We can produce nice looking box plots relatively easily. So you can see here what I'm doing is X is continents. That's going to split it up by the continent. Y is life expectancy. And then we've started box plots, and we've got a 5-number summary here in one line of code of all our variables split by the continent. So we can see outliers. We can see that life expectancy is higher in Europe and Oceania compared to Africa at our data set. Now that's all built into GGplot. There's a number of different expansions. So in this case here, I'm working with the GGpoll package. So I just made this here based on the South Africa parliamentary elections to produce figures like this. You can see this is the code to do that. I don't want to go through this in too much detail. We can use ggpubber, which is another expansion pack for GGplot. And let me just show you what that looks like here. So what am I showing in this figure? I'm showing length and dose. And then we've got 3 different doses and the length of treatment. We have the 5-number summaries here with box plots, as well as actually showing the raw data behind that. and then this is the result of a Kruskal-Wallis test here between these different data sets. So this is quite an advanced figure because we're communicating the actual data itself, 3 different levels, the different treatment effects, the significance of a test between those different effects, different colors going on here. So in one figure, this is communicating a huge amount of data and information to a reader. And then one last one here, I'll show you. So this is, I quite like violin plots. So what we're showing here is the distribution of the data, the 5-number summary of the data at the 3 different doses, the levels of the effect there, as well as then the significance of this Kruskal-Wallis test between these different levels. And you can see here that this is relatively a small amount of code that I've added on to GGplot to have really nice publication-worthy figures. So that's the basics there of GGplot. Some things that I think will take your GGplot skills to the next level. This is a workshop, this video here. It's a 2-hour video similar to this, but by the actual one of the maintainer of GGplot, where he takes you right through the grammar of graphics from basics right through to producing great figures. This is a cheat sheet here for GGplot. And then the place where I often go to start with is top 50 GGplot 2 visualizations. So I go there, one of these 2 links, they both take you to similar links there, and they have the best 50 figures made with GGplot, the actual figure, as well as then the code to make the figure. And that's often where I go to start figuring out what type of figure should I visualize my data and how would I even go about starting. And I use that code as a basis to then build my plot around or tweak it for my data or see, hey, how do you make a figure like this? And I go and find the code and I see, okay, that's how you do it. This is how you do that. You tweak it like that. So there's resources out there. Don't feel that you should be lost and don't know where to start. So if I were you, I would work through these 2 texts to understand the basics of the grammar of graphics. This one's more about the basic fundamental principles of data visualization. Here, Healy actually takes you through building with GGplot, and then look at this to get some ideas of examples of nice figures built in GGplot and to see how they're actually made and start working with the code. And slowly but surely, just think of those layers, building it up one layer at a time. Great, I think that's where I'll leave you. I'll see you in the next session.